And what is AMF? AMF was for maintenance factor. Now, among UF and AMF, it is very easy to find out AMF. AMF is maintenance factor. What is actually maintenance factor? In some project, you clean light every day. And some other project, you never clean light. Let's say in office project, you'll be cleaning the surface of the light once a week, maybe. But in hospital, maybe every day, right? So if you clean light, the light will give you better performance, the better intensivity. And when you don't clean light, the light or fixer will not give you better performance. That is identified here. Now there is a table to explain this maintenance factor. This is the particular table. If the room or the space is clean, the maintenance factor will be high. If the room is not that clean, the maintenance factor will be low. Let's say there are 4 types of occupancy. One is very clean. Hospital, pharmaceuticals, they fall into this, very clean. Clean. Food factories, office and other facilities, they are really clean. Average. Average is like commercial space. For instance, shopping mall will be average clean. And dirty. Dirty, by definition, the places where the process is dirty. There's a painting shop where you usually spray paints. The place will always be dirty. It doesn't matter how often you clean the lights. Or garage. Garage is usually dirty. We usually never clean it that often. So depending on the project, you can choose it from here. And if you have no idea, the suggested one, let's say paper mill. Paper mill is the place where you produce paper. Is it going to be clean ever? Clean. Let's say school. School is clean, very clean, or ever is clean or dirty. The lights of the school, how often you clean? Once a week, once a month, or never, ever, ever? What do you think? School is a common scenario. It's familiar to you. Am I clearly audible to you? I'm not quite sure whether I'm listening or not. I need your input. Without input, I will not move forward. You need to give me input. This is not a radio show where you just listen and do nothing. You have to give input. If you don't understand, raise your voice. The school is clean, average or dirty. How often? Usually the lighting fixture of the school is clean.
It's clean, sir.
clean. So let's say your light is clean. Then you can go for 0.8. Right, for pharmaceutical, it is going to be 0.8 or more than that. So 0.8 is good to go. So we find our maintenance factor 0.8. Okay. I'm erasing all of this. Don't worry, everything is written here. So I just like to write, that's why I wrote. It is 0.8. Now it comes to this UF. UF goes for utilization factor. Then, while you are measuring light in any place, in two ways, you get the final output or result of the lux. One is direct light. What is direct light? This is your surface, and some light will come from the light source directly to the surface. And there are indirect lights. Some light will reflect in the wall and come to here. Some light might bounce in the ceiling and then might bounce in the floor and then again bounce in the wall, again bounce in the ceiling and then come here. So this way we get the final result because of direct and indirect light. Let's imagine two projects, two separate rooms. This is one room. This room is my house in Dhaka. And this is my reading room. This is the table here. I just put only one light here. This light is, let's say, 3,500 lumen and 38 watt. And when I measure the lux, I measure on the surface of the table. But there are some other specification of this room. The wall is white color paint. The ceiling follows the color of the wall, white color. And in the floor, we got a bright color tiles. This is scenario 1. Scenario 2, my house, but back in the village. There, I do not have a reading room, but let's say I have it there. And I also put the same light there, 38 watts and 3,500 lumen. The room are same size. Size is not different, but something is different. The wall is not white, it is green color. The floor is not bright, it is dark color. And the ceiling is somewhat brown color. And after finishing this project, room size is same, height is same, lights are same, the luminaries all are same. Then you went here and measured the lux here in the project scenario 1 and in the scenario 2, you also measured the lux here. Which project will give you better lux? Scenario 1 with the white color and bright color everywhere. And scenario 2, where is dark color and different green and black color everywhere. Which project will give you better lux? Project A or project B? Scenario 1 or scenario 2? Have you ever experienced this one? Let's say you're going to show some villains, and doesn't matter how many light you put there, it seems always dark. Which project will give you better experience, better light?
Senior 1 episode.
And why do you think so? Because of the reflection, right?
Yes,
Say
sir.
for the direct color, both of them are giving same direct color. This is also direct color is the same. But when it comes to indirect color, as it is white, and we know white reflects all the color, it will give you more color here. But for this scenario, this is green. The green color actually absorbs all the colors except green. That's why we see it green. It will not give high reflection. The floor is dark, so the reflection from the floor will not be high enough. That's why the lux will be different. Okay, color is one factor, but there are several other factors too. Let's say we change the luminaries. Luminaries are no longer on the ceiling. Let's say the light is actually hanging here, and the light is closer to the table. Now it will give you more lux on the table, right? As it is closer to the table. So these scenarios has to be identified to do the lighting calculation. And how do you identify this? We identify this by measuring UF or utilization factor. Utilization factor has to be separately calculated. And to do the utilization factor calculation, we first need to know room index. The room index will identify how big the room is, room size, as well as the distance between your luminaries and the surface of the work. So here you see the calculation. Let me write the calculation. Okay, let me write here. So it will be in the same yeah, not room index. Room index is equal to the length of the room multiply the width of the room. You all know this from the AutoCAD file. In the numerator and in the denominator, we have HK. HK is the useful height. So HK is the useful height. What is HK? HK is actually the distance between your luminary and the surface. If the light is far away, the brightness will be less. If the light is closer to the surface, the brightness will be higher. So we need to know the distance between, or we need to address the distance between the surface and the bottom of the light. That is useful height. Usually the useful height is between 1.5 to 2 meters. but it depends on the project. So you exactly have to identify the distance between the luminaries and the surface. Now, this is a industrial project. Industrial project, people work here there by sitting or by standing.
Sitting, sir, maybe.
Oh, industry, you most probably going to stand. But only few places are sitting, like packing room, they sit and pack. But other places they stand, don't sit. So if they stand, the room height is 2.7 meter. Room height is 2.7 meter. Industry, we do not like the pendant light. We actually like light in the mounted in the surface, the recessed light. So if the height is 2.7 meter, where we'll measure the lux as per British standard? Remember, if you stand, it is 1.6 meter, right? 1.6 meter. If you sit, it is 1.2 meter. Then what is the distance between light and the surface? The light and the surface is 2.7 minus 1.6 is equal to 2.7 minus 1.6, 1.1 meter. This is HK. HK is equal to 1.1 meter. Now, if industry people, your customer, if they think 1.6 meter is not their height, they are thinking 1 meter. Then you have to modify this calculation and provide them whatever they need. If you do the same thing in, let's say in the industry, they didn't go for 1 meter. They ask you to do it for 1 meter only, not 1.6 meter. Then it is going to be 1.7, right? The distance between the luminaries and the top of the table. .7 meter. Length width we all know, so that's why I'm not writing it. Again, we need some other inputs here. LEN, length and width. You have to add them. Save it. So what is the length of this room? 4.3 meter, and other side is 6.3 meter. 6.3, 4.3, 1.7, 4.3 plus 6.3. Now we got to do the calculation. If you have calculator, you can help me. 7. 6. We got 1.49 to round it up. It is going to be 1.5. Done. This is room index. Once you get the room index, the calculation is almost done. As you get the room index, now you have to go to this particular table. Now, this particular table will look messy at the first look. Let me explain this one, and it will be easier for you. Actually, it is very simple and straightforward. In the left side, it is written room reflection. C goes for ceiling. W goes for, help me, what is W goes for? If C for ceiling, W for?
Maybe where is sir?
Wall.
Oh,
And F for floor. Ceiling, wall, and floor. These are the reflection index. Where the reflection index coming from? It is actually the color of the surface. There is an intensive table here showing you the color of the surface. If it is yellow brick, it will be 0.5, dark brick 0.4, red brick 0.3, cement 0.27, concrete 0.55, snow white 0.7. You can get it from here. But usually, at the beginning of the project, nobody have any idea what will be the color of the wall and what will be the color of the floor and ceiling. If you have no idea, then you will follow 0.7, 0.5, and 0.2 as per guideline. Now, here the first row 0.7, 0.5, 0.2. Ceiling is 0.7, wall is 0.5, floor is 0.2. For the second row, nothing is written here. So actually it is 0.7. And nothing also written here. This is why it is 0.2. Likewise, we can fill it out. For the next punch, 0.5 and nothing written here. So it is actually 0.5 and 0.2, 0.5 and 0.2. Right? Okay. So let's say we don't know what is the reflection factor here. And then we can go for 0.7, 0.5, 0.2. Usually this data will give you very close data. Well, I suggested one for you at this level to go for this data only. Don't look at other data at the beginner level. Now, there is room index. Room index, it is written here 0.75, 0.75, after that 1, 1.25, 1.5, and go on. What is the room index? Do you know that? Do we have that room index? Yes, we calculated the room index here, remember?
yes, sir, it's a 1.5.
1.5, right, thank you. So 1.5 is in here, fortunately. So if it is here, let's use it, and I'll show you if it is not available here, how to deal with that. It is available here, 1.5. And now, if you go the right side, it is 0.6 and drop down. This is your room index, 0.6. You can use it on the formula presented in the very early of this calculation. I'll come back to this table again, and I'll show you how to find if the data is not accurately available here. Let's say it is 1.5, it is already available here. 2 also available here. But if your room index is 1.75, it is not available here. Then you have to do some calculation to find it out. I'll show it to you later on. Let's use this one, 0.6, the utilization factor. .6, the utilization factor. Now, Let's make it blue color. We are all done. Now we have to do this calculation only. So we have to multiply 500 with 27 and we divided it by 3,500 multiply with 0.6 and multiply with 0.8. You got calculator? Anyone? Help me with this. I might do wrong in calculation. So you also have to do with me. 500. So am I doing the calculation right? Could you please check at your end?
8.3, sir.
8.3.
No.
So 8.03, right? 8.03. So there you need actually 8 lights. Now, if it is a residential project, whatever data you get here, take 1 light extra. Because in residential project, if there is a problem with 1 light, it will take some time to replace that one. Someone have to spare the time and call the electrician. Electrician will buy the light and replace it. But when it goes to industry, you don't have to take anything extra because there will be always some people to just call out and replace it inside the industry. And lights are always spare in the warehouse. So 8 lights is what we require to put it in here, this place.
Sir,
Okay? Yeah. Tell
we have
me.
a question, sir.
Yes, yes.
Sir, if our calculation will be 8.7 like this or 8.6, so how many lights we need, sir? 8 light or 9 light?
If it is 8.03, so it is very close to 8. So I'll take 8 lights here.
Like
So let's say it is
8.6.
like 8.5 or more, then I'll definitely go for 9 lights. Even if 8.4, I'll go for 9 lights.
Okay.
I'll take 1 light extra because you're calculating here 3,500. There might be some wrong with the production of the light. You are not always going to get the exact light. There's also performance issue of the light. That's why you take 1 extra. Okay, but it is very close to 8.03. I didn't look at it.
Yeah.
8 lights we need to put here. Where? In this project. Lighting details, specifications are in here. You can also read this out. Minimalistic yet bold, 50% energy saving, advertisements actually. Flexible, multiple color. Full glow light. Okay, so this light we need to put in this particular project. Now we need to distribute this light so that our U factor, what is U factor? This U value, the minimum versus maximum is well accepted, 0.6 and above. So that's why we need to distribute light. And to do this distribution, we need to do some calculation. Before we proceed to the calculation, let's design the light. Let's make a layer for the light. So how to do the layer? You already know. Layer properties, click here. Already existing layer, which is made by civil engineers or architect, whatsoever, it is not concerned with us. So we'll make one more layer. Let's make it light. And for the light, let's give it a color. Which color you like for the light? Yellow, maybe? Yeah, let's go for yellow because yellow is not used here. This is the default layer color. But there is a problem with yellow. If you print out yellow, it is very hard to notice. Then in that case, you can go for blue color maybe and press OK. This is your layer. But before you exit from this option, right click here and set it current. If you do not set it current, then the design will not be done in this layer. So now the present layer is the light layer. And then go out from here by closing it simply. Now this is our lighting layer, and then we are going to design the light. This is a square shape. This light is 600 millimeter in one side and 600 millimeter in the other side, but it's not vertical. Let's go for ortho. Yeah, I cannot move that now. 600, 600, 600. This is your light. And if you want, you can cross it from this way. It sometimes can put. It is the light, but it has so many lines. Then if you want to use it easily, you can block it into one. So let's copy it here. I can copy from here, clicking this button, copy here. There are two different lights. And what I'm going to do now, I'm going to block one. So I'll make the left click, let the left click go, and let my cursor round the selected points. After that, I'll simply write block. B-L-O-C-K, block. So you see, the block option appear. I'll click enter in the keyboard only, enter. Now I have to provide the name of the light. So let's make the light name 3500 Lumen 600 size 38 watt light. See, now you can select the light at once by clicking anywhere on the lines. But earlier, you couldn't do that. So we got our first light to work with. And then before we move forward, there is a legend here. This legend, people will follow to understand what is the symbol for what. Then this is the symbol for your light. Now copy this. Earlier we copied it by clicking this button. You can do this, or you can just simply write COPY, copy. And you can only, I want to put it in here, but I can only move the right side and bottom, the lower side. I cannot move the corner. How to move in corner? Any idea? What do I stop doing? If I want to move it in corner, how to move? Corner. I cannot move corner. I don't know why I can't move in corners. Give me idea. Again, copy. I couldn't move in corner because the ortho is on. I click ortho, ortho is off. Now I can move anywhere else, anywhere I want to. So I came here and I put it in here. Text, now the text button. Text, come here. Multiple text, okay. Left click. And here I want to put my text. Okay. Now, if you come here, the text height is 900. Someone of you have asked me, maybe in the WhatsApp, right, today or yesterday, my text is very small. I cannot even see it because it is zero set here. If it is zero set here, usually zero is set, then you cannot see the text. What you have to do, you have to now choose your height.
Bro.
Yeah, yeah. Who had the problem with this? Couldn't see the text, very small.
Sammy, the
Yeah.
thing is, it's like, it doesn't grow up. It's just 5. The maximum is 5.
Oh, you have done maximum 5 because you're checking from the drop down menu, right? You don't check it from the drop down menu. Then let me mute someone. Yeah. Okay. You can double click here and you can write whatever you want to write. Numerical value, of course. Try this. Okay. If it is 300, you put it 300 here. And then you can write here. You don't like the font, you go here and change the fonts. Yeah, maybe this font you like or in this font. Yeah. It is here. But it is different from the others. Let's say you want to make all these as small, this similar. How to make all these similar? By doing matching the properties. How to match the properties? Just write match the property. See, match the property. Click on the desired one and click on the target one. See, it is just. Let's do it again. Let's make this look similar to this one. Before that, I write here 38 watt light. And I want to make it similar to this writing. So everything looks uniform. That's why. So I do match property. I take this and I just click and yeah. Now they are all same. Okay. What? This is your light. Now let's put this light in this target one. There are 8 lights. So we can have 2 row and 4 column maybe. Right? 2 rows or 4 column, there is one option. You can also go for 3 rows and 3 column, but you are going to need 1 more lights. So this is the place you put the light first. Copy. Let's put the light here randomly for now. I just didn't do any calculation. I'm just putting it randomly. The whole thing I copied here. Now, what is the problem of this kind of distribution? 4 lights here and 4 lights here. Some places will be very bright and some places will not be bright.
Yes, sir.
Like in the mid portion, there are no lights. But you also need to look uniform. What are the other options I can explore? Give me some more idea. What if we make 3 by 3 and add one more light? Because you see, required is 500 lux. If it is more than 500, until 750 is okay. That's why if I increase 1, it's not a big problem. So let me increase 1. I remove this one, I click this, and I just press the delete button to delete it automatically. Move this to the center. 3, 3. I put another 3. This might look uniform, but we have to exactly pinpoint the distance between this light from center to center. Now, how to do that? First, you have to know what is the length of this portion. Even though you already know, I'm doing it again. It is 6.3 meter. Why it is blue? Because the layer is lighting layer, it is in blue. 6.3 meter, right? Then, how should we measure the distribution? Here, BT standard will help you. Let's go to the BT standard again. The page we are looking for is in the beginning. Yeah, like this one. Is it? Yeah. Not this. I'm looking for this. Let me remove my previous history. Every time I have a new batch, I have to come here and do this once again, again and again. It is very interesting. It never gets old to me. From now, right? For our scenario, our light have 3 columns and 3 rows. 3 columns and 3 rows. The question was, what is the difference between this point and this point? The answer is, you have to know the length and divide it by the number of light. As simple as that. So for our scenario, come to this point, the length is 6.3. And we have to divide it by 3 because there are 3 columns. 6, 3, 7, 8 divided by 3. We get 6378 divided by 3. 2126. Now remove this, click this one, copy, center point. Now we have to put the distance 2126. Done. Okay. And again, you can copy it, take the reference of the other line, and then put it in here. Same thing. So the distance in between is maintained. How far? 2.216 meter. 2126. Okay. And what about the distance vertically? Again, we have to know the length and divide by, remember, 3. Because there are 3 sets of light in this vertical direction. If there are 2 sets of light, then we divide by 2. So 4349 divided by 3. We get 1449.66666. Okay, so let's remove this. Now this one we copy. We can copy it from here. Take the reference, and this is going to be 1449.66666. Done. Okay, and other line will follow the same. So we'll copy the other line. First, we select the lights. How to select the lights? Click, is selected. Click, the other one is selected. Done. Copy. I'm doing the copy by command. Take the reference, put it in here. What is the difference in between these two? 1450. 1/3 of the room width. Then again, we have to put the other 3 lights. How do you do that? Again, copy this and simply put it in here. Done. Do you see any problem with this design? What is the problem? What is the problem with this design?
There may be the top one have some space.
So it is not well distributed. One is in the corner of the wall and another one is far away from the wall.
Yeah.
That has to be, identified. Now, how do we do that? Very simple. It is also mentioned in the BT standard. It should be half of the distance in between these 2 lines from this corner. Half of the distance. Right. Yeah. The distance between these 2 lines are 2126. Now the distance from here to this point will be half of this. Right. So 2126 divided by 2. 2126 divided by 2. 1063. That's the problem, right? So let's find out this point. Now let's take this polygon, start from here and go there, 1063. We'll delete it. Let's make this line down. Okay, let's change the color. Even though this is the layer color, I can do it by my wish. And I made it red, but the red line still is in the lighting layer. Doesn't matter. So similarly, distance between this point and this point should be half of this point and this point. 1450 divided by 2. 1450 divided by 2. 725, but it is actually 1143. Doesn't match. So let's see how it match. Take a polygon here again. Go for 725. So we get a magic corner. I will make it red to just understand it better. So all this light has to move. Now I select all the lights. Copy simply by clicking there. Copy. Click the center point. Okay, I made a mistake. There are multiple lights. So copy might not be a good option here. Let's make Control Z and try to do it again with a smarter command. Something smart. What should we do? Move. Move is better. Take this point and bring it here to the reference point. You're all set. The lighting design is now acceptable, right? And if you do this design and I ask you all those questions, what is the spec of light? You have the answer. What is the lux requirement you met while designing? You have the answer. Because as an engineer, you have to have answer of all the questions. And you got all the question and answers in this particular class. Now what you have to do is to design light for at least 2 of the rooms. At least 2 of the rooms.